So hello everyone, welcome, and this is the first class of our radical chemistry course. So today in this particular lecture we are talking about the little bit of introduction that why radical chemistry was necessary or to learn. Okay, so first let us talk about some environmental aspects. So we all know about the ozone depletions, like ozone layer present in the stratosphere, which actually blocks the harmful UV rays from the coming from the sun. So basically what happened that by using of CFCs like chlorofluorocarbons, so what happened that chlorofluorocarbon liberate the chlorine radical. This particular chlorine radical actually react with the ozone molecule to deplete ozone to oxygen, and this is nothing but a chain radical based chain reaction. And due to this particular chain reaction, what happened, there is a the ozone layer, the thicker ozone layer got thinner, and this is we termed as a ozone depletion or ozone holes. Okay, and if you see here that one Cl radical or chlorine radical comes from the CFC that is used in the refrigerator earlier. So this particular chlorine radical will undergo a chain reaction with the ozone molecule, and then after the ozone depletion, again the Cl radical was generated, which again start the chain reaction. So this is a very cliche form of radical reaction, uh, and fortunately that we have ended the use of CFC nowadays, and this CFC is banned nowadays, and that's why the problem of ozone hole is little bit of solved. Okay, but not only in the environmental aspect, radical present in our body itself also. Like in our body, actually, there was some kind of reactive oxygen species was there. That reactive radical has been formed in our body, and which actually these reactive radicals are for having severe consequences in our body, such as the aging process and as well as the different kind of diseases. So what happened that vitamin E present in our body, actually it atta- undergo a radical reaction with this particular reactive radicals that generated in our body system to make that particular harmful radical to a treatable radicals or non-harmful radicals. So first of all, that this vitamin E actually undergo reaction radical based reaction with our harmful radical present in our body to make them a non-harmful radicals. Like here, that RO radical that is formed in our body by in situ method. Okay, so it will react with the vitamin E to form the corresponding alcohol, and here this is the radical version of vitamin E that is actually uh, non-harmful in our body. So vitamin E actually done this type of radical based reaction. So this also shows the importance of radical chemistry in our body. Now let us talking about the synthetic chemistry pathway. So free radicals are mostly used to generate a polymers. So what happened that there is a initiator was there. So we'll discuss about initiator in the later stage of our discussion. So this particular will undergo heat to generate the radicals, and this particular radical will combine to generate the polystyrene type of chain. And this type of polystyrene are actually used to generate polymers. So radicals also have the synthetic importance in the polymer chemistry also, as well as the industrial point of view. That's why radical chemistry is important to learn. Okay, so let us talk about the little bit of history of radical chemistry. So first denoted radical is this particular triphenyl carbon radical, and this is actually stable radical due to the presence of these three phenyl rings. So what happened that this particular triphenyl bromine are actually react with the silver metal to generate this type of radical. So initially the scientists thought about this is done in the nearly 1900. I doesn't remember the exact year, but nearly in 1900 this particular reaction is done. And so after forming this radical, since it is unstable, as they are treated, this particular system is unstable, so they are actually thought that this particular thing will getting dimerized to form a spin paired molecule, and they are expecting this type of product. But when they are actually do the character analysis of this particular product, then they will get this type of product. And this type of product is only observed if the pathway is undergo a radical based pathway, not the normal addition elimination type of pathway. So uh, for their further investigation, they will understand that no, this is a new concept. There is a concept of radical chemistry, and the Morse Gunwerk, they are the father of radical chemistry. So this is very much a small history regarding radical chemistry. This is not that much important for the exam purpose, but for the general knowledge purpose, it is important. So with this, we have to end this particular class. So in the next class onwards, we are actually entered the part of radical chemistry. So we are in next class, we will discuss about that what is actually a radical, how it is different from a carbocation and carboanion, as well as we are discussing about some kind of mm, radical generation method and all. So please stay tuned for that particular lecture. So with this, we have to end this particular lecture. So thank you for listening.